All right, so let's discuss complex numbers, okay? Complex numbers. Complex numbers, we typically write in the form A plus BI, where A is our real number and BI is the imaginary piece. So let's see what we would do if we were asked to write this as a complex number. Well, the way we would write this is, well, we need an A term, and since we don't have a number, we would write 0 plus, and then this is our B term, so this would be 0 plus 8i, okay? If you're asked to write this and to decide if this is an imaginary or a real number, well, because it has this I in it, it's going to be an imaginary number, and the way you would write this in that A plus BI form would be 6 over 7 plus 3 over 7i, okay? And this would be an imaginary number, okay? Say you're given the square root of 23 and they want you to write that as a complex number. Well, that would be the square root of 23. That would be the A piece. And since there's no I piece, we would write plus 0i, okay? And that would be a real number because there's no imaginary piece, okay? Another thing about imaginary numbers is that I is equal to the square root of -1, and I squared is equal to -1, okay? So let's look at some problems with these imaginary numbers. Say we have 3 plus 5i plus 3 minus 4i, okay? We're gonna combine like terms. Now in this case, I'm gonna use the imaginary number piece as I'm going to kind of view it like a variable. So I'm going to put like terms together. So 3 plus 3, those are like terms, and then plus 5i minus 4i, which gives me 6 plus 1i, or just I, okay? Now we would not combine these two. We would not get 7i because this number does not go with the imaginary piece, okay? So let's look at another problem. 7 minus I minus 3 plus 4i, okay? Well, I'm going to combine like terms. I'm going to distribute the negative, so I have 7 minus 3, and then minus I, and then this is going to be minus 4i. Well, this gives me 4, and this negative 4i gives me negative 5i, okay? And again, we would not combine the 4 and the 5i, okay? All right, what if I have negative 4i times 3 minus 2i? Well, let's distribute. So negative 4i times 3 is negative 12i. Negative times negative is positive. 4i times 2i is 8i squared, which gives me negative 12i. I squared is -1. -1 times 8 is -8. Now I want to write this in the A plus BI form. So I would write this as -8 minus 12i. Again, I'm not going to combine these two because this does not have an I and this one does. Okay. All right, what if you're given this? 2 minus 3i and 6 plus 3i, okay? Again, we're gonna FOIL this back out. So first outer, inner, last. 2 times 6 is 12. So that's first. Outer is my 2 times 3i, which is a positive 6i. Inner, negative 3i times 6 is negative 18i. And then last is 3i times negative 3i is negative 9i squared. Now we're going to combine like terms. So I have 12 plus 6i minus 18i is negative 12i. And I squared is -1. -1 times -9 is positive 9, which gives me 21 minus 12i. Okay. All right, so let's go to the next page. Let's try some more. What if I had square root of 3 minus I and the square root of 3 plus I? Well, square root of 3 times square root of 3 is the square root of 9, which is just 3. And then I have plus the square root of 3 times I, and then minus the square root of 3 times I. And then negative times positive is negative I squared. This term cancels with this term, leaving me 3 minus I squared, where I squared is negative 1. So this is 3 plus 1, which is 4. Okay, so sometimes you'll start out with an imaginary number and end up with just a real number. Okay, and let's try another one. Let's do 2 plus 6i, quantity squared. Well, that just means this is 2 plus 6i times 2 plus 6i. 2 times 2 is 4. 6i times 2 is 12i. 6i times 2 is 12i. 6 times 6 is 36. I times I is I squared, which gives me 4 plus 24i. And this is minus 36 because I squared is negative, negative 1. 4 minus 36 is negative 32 plus 24i. And that's in that a plus bi form. Okay. All right, then some of these want you to turn these imaginary numbers into trig functions. So say they ask you for 7i, and they want you to write that in this r times cosine theta plus I sine theta. Okay, so remember that r is equal to the square root of a squared plus b squared. Okay. And in this case, 7i can be written as 0 plus 7i, where this is my a plus bi. So in this case, my a is 0 squared plus 7 squared, which is 7 squared is 49, square root of 49 is 7. So my radius here is 7. All right, since the I piece goes with sine, I have 7 is equal to r sine theta, where my r is 7. So 7 sine theta, divide both sides by 7. This gives me sine theta. And to solve this for my angle, I need arc sine of 1. Arc sine of 1 is 90 degrees. So for this problem, your 7i is going to be your r, which is your radius, which is 7, times cosine of your angle, which is 90 degrees, plus I sine of 90 degrees. Okay, so that's the answer to that one, right? One quick comment, if you end up with, say, negative 1, so say you had calculated this, maybe this had been negative 7i, okay? Let's look at that. Well, if this is negative 7 is equal to r sine theta, well, remember here, r is going to be the square root of 0 squared plus negative 7 quantity squared, which is going to give you 7, because negative 7 times negative 7 is positive 49, square root of 49 is 7. So we end up with negative 7 is equal to 7 sine theta. Okay, divide that by 7. You end up with negative 1 is equal to sine theta. So theta is equal to arc sine of negative 1. Now, when you plug that into your calculator, you're going to get negative 90 degrees. Now, here's the thing. You don't want to write negative 90 degrees. So think about this, okay? 90 degrees, we always go counterclockwise. That gives you that 90 degrees. But when it's negative, they're wanting you to go this direction, okay? That negative 90 degrees. So that degree angle, so from here to here, is 270 degrees. So this answer would be 7 cosine of 270 degrees plus I sine of 270 degrees. Okay? So just kind of keep that in mind. Okay? Let's try another one. Let's try negative 6i. And so what we're going to have is our radius is going to be the square root of that a squared plus b squared, which is going to be, that's going to be the positive 36. Square root of 36 is 6. So we have 6 is equal to r sine theta, where r is 6. I'm sorry, negative 6. R is 6 sine theta. So this gives us sine theta is equal to -1. So arc sine, theta is equal to arc sine of -1. And remember, in your calculator, it's going to show -90 degrees. So this gives us 270 degrees. So negative 6i is equal to 6, because that's my r, cosine of 270 degrees, plus I sine of 270 degrees. Okay? All right, what if you're given this one? -5 plus 5i. Okay, and you're asked to turn that into your r times cosine theta plus I sine theta. Okay, well, first let's figure out what r is. R is going to be the square root of my a squared. Well, my a is -5 plus my b squared, which is 5 squared. Okay, well, that gives me the square root of 25 plus 25, which is 50, which gives me 5 square roots of 2. Okay, because square root of 50 is equal to 2 times 25. Square root of 2 times the square root of 25 is 5. So 5 times the square root of 2. So 5 square roots of 2, in case you needed to see that. Okay, so that's what r is equal to. So in this case, we have, let's do -5 is equal to r cosine theta. So let's just do that one. Let's do r cosine theta. So this is -5 is equal to r, which is 5 square roots of 2 cosine of theta. So divide this. So you end up with cosine theta. So theta is equal to arc cosine of -5 over that is -1 over root 2, which is 135 degrees. So my answer is my -5 plus 5i is going to be r. I'm sorry, r is 5 square roots of 2 times cosine of 135 degrees plus I sine of 135 degrees. Because again, your thetas are still going to be your thetas. Okay, this is an I, by the way. Okay. All right, so that's it for this section. Make sure if you have any questions that you direct them to me, and good luck.